eliminating group hydrogen. Okay, at sixth position was this first sixth. Another product I want to show. So this is minor, major, minor. Okay. So now you can compare. You can compare result of these two. Okay. Result of this two products. So you can see here also 1,2 olefin is formed. Here also minor is major product is 1,2 olefin. Here also minor is 1,6 olefin is forming. 1,6 olefin is forming. So you can now see that both results are the same. How? So pay attention. What structure of this one we have drawn over here. So both compound they are cis. They are both are cis. In one, both are present above the plane. In another one, both are present below the plane. Both these cis compound they are giving the same result over here. Exactly same result over here. In with both cis compound, we almost get 98% more substitute olefin in both these things, and minor is the 1,6 olefin is forming. Okay. So this is the beauty of this reaction. If you go step by step with all those structure, once you come to know how to draw the structure, once you come to know where the anti-relationship is present, where the syn relationship is present, then definitely your product prediction is not that of wrong compared to whatever you are guessings are there. Okay, so these two cis form they use the same product. Now we will shift to the remaining trans conformer. Okay, so we have seen one trans conformer over here, in which the methyl group is above the plane. In this trans conformer, methyl group is present below the plane. Chlorine group in first one, chlorine group present below the plane. Here, chlorine group is present above the plane. Okay, so we will see now write how to write in chair conformer, how to flip that one, and then we will go for the product formation. Okay. Okay, so this one here, I will draw now the substituents present in the this one. Now first, chlorine is present, chlorine above the plane. I will draw simply above the plane, equatorial. Methyl group at second position, below the plane. So this is equatorial. Okay, now I will draw remaining what's present here, hydrogen. Okay. So here I will draw hydrogen is present. Is present. Okay, so now six carbon atom. One is above the plane, one is below the plane. Hydrogen. So six carbon atom, one hydrogen present above the plane and another one below the plane. Now here the elimination of this chlorine is less because this is equal replaced. So with this one, okay, this carbon single bond is in anti-periplanar. This has 180 degrees centigrade. Anti-periplanar. Okay, anti-periplanar. Here chlorine and hydrogen anti-periplanar. Now switching the molecule, flipping the molecule. Write down now. Substituent present. So now flipping equatorial chlorine. Equatorial chlorine becomes axial now. Over here, chlorine. Draw hydrogen. At second position, equatorial methyl groups becomes axial, and axial hydrogen becomes equatorial. Now at sixth position, one is axial, one is equatorial. Okay. Now write down which are anti-periplanar region. Now chlorine is axial, so definitely this is the most susceptible to eliminate. Now here hydrogen is axial. This one is going to undergo elimination reaction. So these two have anti-periplanar relationship. What degree? Anti-periplanar. You can see this is the most unstable structure. Okay, this chlorine is at axial position here. Also, methyl group is also axial. This is most unstable structure. Both are axial. Now you have to search which one is the second most unstable structure. Hmm. So you can see over here. This one is most unstable. You can see over here. This methyl and this chlorine. They are axial. This is also most unstable. This is also most unstable. You can see now in two this axial and axial. That means sorry, trans substitution. This trans and this trans. These two only shows most unstable conformer in which both substituents, methyl group and chlorine, they are anti. They are present axial. So it needs a lot of energy in kilocalorie or kilojoule. It needs more energy to stabilize this chair conformer. Okay, so that's why this is most unstable. So always most unstable conformer is trying to get more stability. It's trying to achieve the stability by eliminating out of these substituents. Okay, so here there is a possibility of elimination of chlorine. Don't show elimination with methyl group. Methyl group is the worst living group. Chlorine is the best living group. So only there is possibility of elimination of HCl. Don't eliminate CH4, methane. Okay, so that is the worst chemistry. So here's only elimination of chlorine is the very best living group. Best, okay, you can say best living group. So it will eliminate faster and it's giving stability to this molecule. Now you can see this trans conformer is giving most unstable molecule. Also in last year in this conformer also uh, the this one is the most unstable where chlorine and methyl group is present in axial position. This is the most unstable, so definitely, and that one is also having only anti-periplanar relation. So definitely it will undergo elimination reaction to give the most stable product. So now the thing is the position, the 6 carbon atom and first carbon atom elimination. So I will draw here again, draw 3, 4, 5, 6, first and 6 carbon atom. So here, okay, this is the major product is forming, and plus this molecule also undergo the elimination reaction. First carbon atom and first carbon atom and from 6 carbon atom you can say. Uh, so okay, so first and second, sorry. So first, second, third, fourth, six. Okay, so this is minor. This is the major and this is the minor. You can compare in both cis compound, first second is the major. In trans compound, first six, the olefin forms at first and sixth position, this is the major, and olefin forms at the first and second, this is the minor. So this is here is the major product. So it will be too too crowding. Now here we will see, now here we didn't show any product formation. Now this one is the most unstable. Okay, this is the most unstable conformer, so obviously this will give the major product. So I will draw here now major product from this unstable conformer elimination. So this is the product formation. Now the hydrogens will emit from first and 4, 5, 6. So carbon double bond present over here, methyl group present at the second position. Plus this compound will also this less stable. This more stable conformer also gives the one product, but that should be minor. So 1, 2, 3, 4, 5, 6. That will be the second position elimination. So when you can see this one, this product and this product, These are the same from the trans substituted 1 chloro 2 methyl cyclohexane. The same product they are giving, and cis substituted things you can see the same product they are giving. So in this way I am trying to explain why it should be peculiar to draw each and every orientation of stereochemistry in chair conformation. Once you learn how to draw the orientations of these four things, go for to draw the chair, try to figure out which one is the most stable first, which one is the most unstable first. Okay, now here if you will see which one is the most stable, now we will figure out which one is the most stable, where the chlorine and methyl group which both are equatorial, so that conformer will be the most stable. I think there is no, so all these four, in all these things you can see. Okay, I think this here is chlorine and methyl group. These two are these are equatorially placed. So I think this is the most stable. This is stable, most stable. I am saying stable. Here also chlorine and methyl group, they are equatorially close. So this is the most stable. So you can see trans conformer is giving most unstable most unstable chair conformation as well as most stable conformation. Okay, so most stable, most unstable, most stable. Here also you can see here trans conformer only gives the chair conformation in which chlorine and chlorine doesn't have any antiperipheral relationship, but in most unstable it has antiperipheral relationship and these things. Okay, so these two are contrast to each other and both showing most stable unstable groups. These two are okay, they are same in cis conformer, and all these four conformations of this cis cyclohexane, they are having stability in the middle of this all this thing. Okay, so I have written 1 2 3 4 5 6 7 8 from the from this is only one molecule. Okay, this is only one molecule, just we draw its stereochemistry. Okay, thus we have drawn the stereochemistry. On the basis of this stereochemistry, we have done all these 8 different forms, and out of them we came to conclusion. Okay, what will be the product. Okay, the same theory you can apply for the SN1 nucleic substitution reaction, SN1 and SN2 also. Okay, there are also, so for that one, first you should be able to draw all these chair conformations properly. So in this way, the why, how the groups should be anti-periclinar to each other, how you can write the chair conformation, and how you can go for the conclusion of the which product predominates, which product the major, which product will be the minor. Okay, so like that. So thanks for watching.